In the last hour before night settles, when the forest exhales its heat into the open spaces around human settlements, a strange gradient forms along the edges of Amazonian villages. Warm timber walls radiate the day's stored energy. Livestock corrals hum with the metabolic heat of domestic animals, and the packed earth footpaths still hold the fading warmth of footsteps. To us, these are familiar signs of evening. To a jaguar, they are distortions in the thermal landscape, subtle zones of contrast that map out the boundaries of human life. From the tree line, the cat watches this shifting mosaic, its pupils slowly widening as colors drain from the world and the forest enters the spectrum where jaguars see best. This moment, poised between day and darkness, is when the village becomes a hunting ground, not by choice or malice, but by the merging patterns of ecology, opportunity, and predatory memory. Jaguars do not begin their relationship with humans as enemies. For most of their range, people are simply noisy, unpredictable primates that smell strongly of smoke and soap, a signal to stay away. Yet, in remote corners of the Amazon, where forest loss tightens habitat, river fisheries collapse during drought, cattle replace native herbivores, and dogs roam the margins like pale shadows of ancestral prey, the jaguar's risk threshold shifts. A predator built to test the world with stealth and curiosity begins to explore the edges of our lives, just as it once tested capybaras grazing at sunset or peccaries resting in the undergrowth. Hunger and opportunity compress into the same narrow band of twilight, and a cat that once avoided human scent now follows it down the pathways that thread from forest to home. To understand why these encounters escalate, we must first understand the jaguar's evolutionary machinery. Unlike leopards or tigers, which often aim for the throat, the jaguar's entire lineage is geared toward cranial kills. Its skull is compact and heavily vaulted, its jaw muscles arranged not for slicing but for crushing, its canines thickened for punching through the armor of ancient reptiles. This is a predator shaped by millennia of hunting animals with dense bone or protective shells, turtles, crocodilians, armored fish. When such a creature applies that same killing strategy to a mammal, whether a tapir, a dog, or a person, the result is instantaneous. The jaguar's bite force, the highest relative to body size among big cats, allows it to pierce a skull or sever the upper spine with a single decisive clamp. This is not savagery. It is evolutionary precision, the refinement of a method that wastes no energy and gives prey no chance to respond. Around villages, this anatomical advantage becomes even more decisive. Human structures, raised platforms, clay steps, narrow alleys between houses, create choke points and height differences that favor a cat accustomed to attacking from above or behind. The jaguar uses these spaces exactly as it would use riverbanks or root tangles, not as human environments, but as topographic features. A fisherman walking home along a path lit only by a kerosene lamp becomes, in the jaguar's sensory world, a warm-bodied mammal moving through a predictable corridor. A child playing near a chicken coop becomes a small, fast-moving silhouette framed by the dark. A hunter returning at dawn, fatigued and carrying meat that masks his personal scent, may appear as nothing more than another animal emerging from the forest. Jaguars do not anthropomorphize, they read shapes, movements, and patterns of vulnerability. When the ecological circumstances align, a human becomes indistinguishable from the prey template engraved by millions of years of ambush predation. Documented attacks in the Amazon reveal this chilling convergence. In some river villages, jaguars learned to watch fishermen cleaning their catch at dusk. The smell of blood drifted through the trees, drawing cats to the edges of the clearing. Over time, a few individuals tested the space more boldly, approaching silently from downwind, slipping between canoes, studying the footpaths. When prey became scarce during severe dry seasons, the jaguar's calculus shifted. It targeted not the fish scraps left on the bank, but the people themselves. In several cases, men were taken from behind while bending to wash their hands, their bodies pulled into vegetation so dense that even a collective search found only drag marks and disturbed sand. Other incidents involved children gathering fruit near orchards, their small size and erratic movement matching almost perfectly the predatory triggers that would normally be aimed at armadillos or young peccaries. Such events are rare, but they reveal the jaguar's capacity to adapt its hunting strategy to human behavior. In one incident recorded deep within the Brazilian state of Pará, a jaguar repeatedly watched a particular path used by villagers to reach a stream. The animal positioned itself above a slope overlooking the trail, using a fallen log as concealment exactly as it would when ambushing monkeys or deer. When a young boy came down the path carrying a bucket, he met the full momentum of a predator dropping from above, a technique observed numerous times against natural prey. The jaguar aimed for the skull, as always. Only the intervention of adults nearby prevented a fatal attack. But the anatomical signature of the bite left no doubt. The predator was not experimenting. It was executing its standard kill program. Even livestock, often assumed to be safe near settlements, contribute unintentionally to this dangerous shift. Cattle provide a dense, slow-moving calorie source, far easier to kill than a white-lipped peccary or a forest deer. Once a jaguar learns to breach a cattle fence or exploit a gap in the posts, it returns repeatedly, refining its approach. Dogs, which patrol the margins between forest and yard, become secondary prey, their barking drawing the cat closer, their frantic movement triggering pursuit. Over time, the predator's fear of human presence erodes. The jaguar begins to associate the cluster of buildings not with danger, but with predictable, high-value food. In ecological terms, the village becomes a watering hole for a carnivore that does not understand political boundaries or property lines. From here, the probability of a human attack increases with each successful night of hunting. As the camera of this chapter moves through the scene, the forest's sensory tapestry deepens. Listen to the insect chorus thickening with humidity. Watch the moisture rising from the thatched roofs as heat escapes into the cooling air. See the faint glow of cooking fires reflecting off standing water. Each of these environmental signals creates an acoustic and olfactory trail that a jaguar can read with astonishing fidelity. Their night vision, optimized for low light contrast, allows them to track even slight motion. The swing of a lantern, the tilt of a human head, the rhythmic shift of weight from one foot to another. Their whiskers register minute air currents around corners, helping them predict movement without direct sight. Even the soles of their paws detect vibration patterns through the ground, giving them a primitive form of seismic awareness that helps them track prey in darkness. When the jaguar finally moves in, it does so with a confidence that borders on inevitability. It selects a vector of approach, often downwind, often shaded by vegetation or structures, and aligns its body behind cover. Its breathing slows, heart rate dropping into the pre-ambush rhythm common to apex predators. Muscles coil beneath the patterned coat, the rosettes breaking up its outline against leaves or mud. The jaguar waits for a back to turn, for a head to dip, for the fleeting moment when human awareness narrows. Then the attack unfolds in less time than it takes to draw breath. A silent rush, a leap fueled by explosive hind limb strength, and the bite, always the bite, delivered to the skull or upper neck with lethal precision. For the victim, there is no cinematic struggle. The power differential is so extreme that resistance collapses instantly. A jaguar's jaws can generate pressures exceeding 1,500 psi, enough to perforate bone with a single clamp. Once contact is made, the outcome is effectively sealed. Humans do not fight back against a jaguar ambush. They simply disappear into the predator's sequence of instinctive behavior, becoming another body dragged into the forest with the same mechanical efficiency applied to capybaras, deer, or caimans. And this is the unsettling truth. In certain corners of the Amazon, humans are not special. We are medium-sized mammals moving through a habitat governed by sensory rules that are not ours. The jaguar does not perceive our tools, languages, or technologies. It reads motion, heat, isolation, fatigue, small silhouettes, predictable routines. In its world, those characteristics belong to prey. And when ecological pressure pushes the predator closer to our settlements, when the forest's natural rhythms tilt out of balance, the jaguar simply extends its hunting range into a new patch of territory, one marked by gardens, fences, and the soft glow of lantern light. For the villagers who live here, caution becomes a form of coexistence. Paths are cleared with greater visibility. Children are kept indoors at dusk. Dogs are restrained not just to protect them, but to prevent them from drawing predators closer. Fires burn through the night to create flickering pockets of illumination that disrupt the cat's approach. Yet, none of these measures alter the core ecological reality. The jaguar remains a silent, calculating hunter, operating at the boundary where human life meets the forest's patient, ancient continuity. In these liminal spaces, we learn the true meaning of the Amazon's hierarchy. We walk upright, speak complex languages, and reshape landscapes with our hands. But when the last light drains from the sky and the forest becomes a domain of shadows, we revert to our biological origins. We are animals in a predator's territory, and in the eyes of the jaguar, moving through the dim glow of a village evening, we are simply one more warm body entering the zone where the silent stalker waits. The shallow rivers of the Amazon are deceptive places. Their surfaces look calm, sometimes glassy, sometimes rippled only by wind or the passing of a low canoe. But beneath that thin, reflective layer lies a world of suspended silt, drifting leaf fragments, and thick brown water so dense with organic matter that vision dissolves within arm's reach. People who live along these waterways grow up stepping into this opacity without hesitation. To fish, to bathe, to gather water, to cross from garden to forest. In these places, you learn to trust your feet more than your eyes. You feel the contours of submerged logs, the gentle pull of currents swirling around your ankles, the occasional brush of a fish bumping past. Yet the same invisibility that comforts local familiarity also hides the presence of a predator, adapted to exploit this blindness with exquisite precision. The green anaconda, a serpent so massive that the river itself seems to shift when it moves. To enter these waters is to share space with a creature perfectly tuned for ambush in low visibility environments. The anaconda's camouflage, a lattice of black ocular spots on olive skin, was not designed for clear water. It was sculpted by evolution to disappear in turbidity among floating debris and submerged roots. When a fisherman wades into water barely to his waist, he often does not realize he is passing through the same thermal pockets the snake uses to regulate its vast body mass. Warm shallows act as natural solar batteries, collecting heat from the sunlit surface and holding it through the evening. The anaconda settles into these zones to conserve the energy required for digestion and to prime its muscles for bursts of predatory power. In the brown water, the border between river and reptile becomes indistinguishable, and a human crossing the channel enters a sensory universe where the snake, not the person, defines the rules. Most attacks begin not with intention, but with a mistake. The predator's evolutionary template colliding with the unfamiliar dimensions of its human neighbor. Anacondas hunt by detecting disturbances, pressure waves, vibrations, and the displacement of water by large animals. A capybara wading in, a caiman drifting close to shore, even a heavy-bodied bird swimming after fish. Each generates a consistent pattern of movement that the snake recognizes. Humans, with our irregular gait and upright posture, resemble prey only in outline and momentum. But in muddy water, outlines blur, and momentum alone becomes a trigger. A fisherman taking a step from sand to mud might feel the sudden shift of something muscular brushing past his shin. Before he makes sense of the sensation, jaws lined with backward curving teeth latch onto his leg or torso in a violent, suction-like grip. The snake is not assessing identity. It is executing a reflex that has worked for millions of years on mammals and reptiles that never had a chance to question what struck them. Once contact is made, the river changes. Water explodes upward as the anaconda twists to reposition its coils, using the victim's own movements as leverage. In the murk, visibility drops to total blindness. The fisherman cannot see the coils forming around him, only feel the rapid tightening as bands of muscle close in a pattern older than human history. Anacondas strike not with venom, nor with a cutting bite, but with the physics of hydraulic collapse. Their musculature is arranged in loops along the body, allowing pressure to be applied evenly across several points at once. Each time the victim exhales, even partially, even in a cry of panic, the coils constrict further, tightening to the new reduced volume with mechanical indifference. The chest cannot expand. Air cannot return. Panic turns from an instinct into a trap, because every struggling twist signals the snake to reinforce its hold. If the coils wrap high, around the chest, shoulders, or upper abdomen, the sequence becomes lethal with catastrophic speed. Breathing stops almost immediately under the weight of constriction. Blood flow to the brain drops, not because the snake squeezes life out in a poetic sense, but because circulation collapses under external pressure that exceeds venous return. This is not a slow suffocation, but a cardiovascular shutdown. The heart cannot push blood through compressed vessels, and consciousness fades. Most anaconda victims never feel themselves dragged underwater. By the time the snake shifts from subduing to repositioning, the nervous system has already shut down. These attacks, though rare in the context of millions of annual human-river interactions, leave a deep scar in local memory. Stories ripple outward through communities, traveling along trade routes and river channels, accumulating detail like sediment settling in oxbow lakes. In some accounts, fishermen vanish without a sound. Their canoes drift empty until found lodged in vegetation downstream. Search parties follow drag marks into flooded forest, only to find the water too dark and too deep to reveal anything. In other stories, anacondas discovered by hunters contain swollen bulges beneath their ribs, shapes unmistakably human. When such snakes are killed and cut open, the grim anatomy confirms what the villagers already feared: wrists still bound by fishing line, portions of clothing intact, sometimes even tools swallowed along with the body. These are not myths. They are case reports scattered across decades, carried in memory rather than in scientific journals, because remote regions rarely intersect with formal documentation. From an ecological standpoint, these tragedies make sense within the anaconda's natural predatory framework. A fully grown female, often exceeding 5 meters and sometimes pushing past 7, is energetically expensive to maintain. Such snakes rely on infrequent but massive meals, capybara, deer, caiman, that provide enough calories to last weeks or even months. A human of adult size fits comfortably within that energy budget. To the anaconda, the opportunity is not symbolic or moral. It is biological. Once constriction succeeds and the prey goes limp, the snake begins the process of repositioning its jaws, aligning them around the widest part of the body. Its ligaments stretch dramatically, the upper and lower jaws moving independently, the glottis extending outward to maintain airflow during ingestion. In cases where humans have been found inside anacondas, this process was interrupted only because the snake was discovered before digestion began. Had it not been disturbed, it would have completed the sequence with the same methodical efficiency applied to any large prey. But to fully understand the threat, one must also understand the river itself, not as a background, but as an active participant. The Amazon's flood pulse, rising and falling by meters throughout the year, reshapes the hunting landscape continuously. During high water season, anacondas move into flooded forests, where their massive bodies glide between submerged roots, branches and trunks. This is where many human encounters occur. People crossing what looks like a shallow forest floor are in fact walking atop a submerged habitat full of thermal pockets and ambush points. The snake may be resting, digesting, or simply using the warm shallows as a thermoregulatory advantage when someone wades into its coil radius. Thermal imaging studies show that anacondas select water depths that balance heat retention and concealment. Humans entering these micro-habitats unknowingly step into zones where the snake is already primed for defensive or predatory reaction. The snake's sensory adaptations make the encounter even more one-sided. Anacondas have pressure receptors along their jaws and body that detect minute vibrations. They do not see well in dark water, but they do not need to. Water movement tells them the size and speed of what approaches, the direction of travel, even whether a potential prey item is injured or fatigued. When a person steps into the river, the snake reads their mass and displacement long before physical contact occurs. Its strike is not a surprise attack in the narrative sense. It is a response to a fully mapped hydrodynamic signal. Survival becomes possible only if someone nearby intervenes immediately. Groups can pry coils apart, force leverage against the snake's loops, or use tools to disrupt the constriction. But a lone victim has almost no realistic path to escape once the coils seal around the torso. Human limbs are too weak to overcome the distributed pressure of a 100-kilogram serpent, and the brain begins shutting down from hypoxia within moments. Most survivors describe the same sequence: a violent impact, a tightening grip, a chest that cannot expand, and then a dissipation of sound and sensation as consciousness fades. If help does not arrive in time, the river carries the story forward. To walk these rivers with understanding is not to fear them, but to respect the ecological truth they hold. The Amazon is a system of layered lives, each with its own strategies for surviving, hunting, and conserving energy. Humans, despite our tools and our sense of ownership over the landscape, enter this hierarchy as biological participants. In the eyes, or rather the pressure-sensing musculature, Of the anaconda, we are one more large-bodied organism moving through a medium that erases identity. The snake does not distinguish between a fisherman gathering water and a capybara crossing a channel. It responds to movement, mass, and opportunity. And when opportunity aligns with hunger, thermoregulation, and the silent advantage of the river's opacity, the result is a confrontation where human survival hangs not on strength or skill, but on whether another person is close enough to act. The truth is stark. Once a large anaconda establishes a full wrap in deep or even waist-high water, and there is no one nearby to pull it away, the odds of survival collapse to nearly zero. The river closes over the struggle, the water settles, and the forest absorbs another life into its endless cycle of predation and decay. Here, in the flooded lowlands and silty shallows, the Amazon reveals one of its harshest lessons. The river does not care what we believe we are. It only cares how we move, and the anaconda is waiting for that movement, coiled in the silence beneath our feet. The edges of Amazonian waters are among the busiest interfaces in the rainforest. They are stages where human life and river life fold into one another with almost choreographed regularity. At dawn, women kneel at the shallows to wash clothes, rhythmically beating fabric against smooth stones as mist rises in pale sheets above the surface. Children wade knee-deep, their laughter echoing off mud banks while they chase minnows that glitter through the top few centimeters of sunlight. Fishermen gut their catch just centimeters from the waterline, rinsing knives and hands in currents that swirl red for a moment before the river absorbs everything. These margins are practical, communal, familiar, and for that reason dangerously ordinary. Because just beneath the thin membrane where air meets water lies a lineage of predators whose entire hunting strategy depends on routine, the caimans. The Amazon's caimans, from the broad-headed black caiman to the more numerous spectacled caiman, are masters of stillness. Their ambush behavior begins before a human ever notices a ripple. A caiman drifts into position at the edge of a backwater pool or slow-moving channel, then settles low in the water until only the eyes and nostrils remain above the surface. The shape is unmistakable once recognized: a narrow snout, two ridged eye sockets, a faint gleam where sunlight glances off the keratin armor. But recognition is rare because the reptile's entire evolutionary trajectory has refined the art of vanishing into an element that blurs outlines, dampens color, and rewards immobility. Humans scanning the waterline often mistake vines, branches, or floating debris for the real thing, while the caiman, perfectly still, calculates distance and opportunity with the patience of something that has survived unchanged for tens of millions of years. To understand why the water's edge is so perilous, one must understand how caimans interpret movement. Their sensory world is not dominated by vision, but by pressure. Along their jaws lie small pits, integumentary sensory organs, that detect minute vibrations. A foot shifting on wet mud, the splash of a hand rinsing fish scales, even the slow rocking of a canoe against a submerged branch sends pressure waves through the water. To a caiman, these signals reveal size, proximity, frequency of movement, and potential vulnerability. Humans leaning over to wash clothes or scoop water appear not as distinct beings, but as silhouettes that repeatedly break the boundary between air and liquid, an irresistible invitation for a predator built to strike from below. The attack itself is shockingly fast, powered by a sudden conversion of stillness into explosive momentum. A caiman lurking at the edge of a channel may remain motionless for an hour or more, conserving energy and waiting for the precise moment when a limb leans too close. When the opportunity appears, the lunge is almost instantaneous. A forward thrust of the torso, jaws opening wide, teeth locking onto whatever part of the intruding body presents itself first. The strike is not a test. It is commitment. Once the jaws clamp, releasing is not part of the plan. What happens next is a sequence older than human presence in the basin. The drag. Humans, with their high center of gravity, lose footing easily on the slippery clay banks. The moment a limb is caught, arm, hand, leg, or even shoulder, the victim's balance collapses, the body tilts forward, knees buckle, and gravity does the rest. The caiman uses this advantage, pulling backward with immense force generated by its tail and torso. The victim, shocked by the sudden attack, instinctively resists by pulling away, but that only gives the caiman more leverage. The water becomes an accomplice, reducing friction and amplifying the reptile's ability to maneuver its prey. Once submerged, disorientation takes hold. Visibility drops to zero as the water clouds with disturbed sediment. Mud fills the nose and mouth. The reptile twists, turning the body on its axis, not a full crocodilian death roll, which black caimans can perform, but enough rotational force to destabilize and stun. During these rotations, lungs inhale muddy water, a reflex triggered by panic and lack of orientation. In many documented cases, drowning occurs before the caiman inflicts any additional trauma. For the predator, these actions are automatic, guided by a nervous system optimized to exploit the advantages of water. Arms, legs, and torsos are simply shapes that resist motion, objects to be everted, unbalanced, and subdued. Humans are not special prey, only another struggling organism at the surface. When a caiman grabs a limb, the evolutionary script has already begun. Night amplifies this danger. Many Amazonian communities rely on narrow tracks that flood seasonally, turning footpaths into waist-deep corridors of slow-moving water. Crossing these at night, especially after rainfall, becomes a gamble. The black caiman, a giant capable of reaching lengths over 5 meters, often uses these flooded tracks as shortcuts between river systems. A person walking through such water may feel only a subtle pressure or brush before a sudden weight clamps down from the side. Several fishermen and travelers have disappeared from these makeshift aquatic passages, their final moments occurring in complete darkness. Canoes offer no guaranteed safety. In certain documented cases, fishermen cleaning fish at the side of a small boat have been pulled overboard by caimans lunging upward, jaws snapping around a dangling arm or hand. The canoe rocks violently, the fisherman loses balance, and the predator pulls him into the turbid water beneath the hull. Caimans understand the geometry of boats instinctively. The edges are low, shadows cover their approach, and the predictable overhang of human limbs provides a clear target. Once underwater, the reptile can continue its drag and drown sequence with the same efficiency it applies to capybaras or birds caught near the surface. To see this from the reptile's perspective requires shifting to a sensory modality few humans ever experience. The caiman's body is a conductor of tactile information. Its tail senses turbulence. Its jaw pits register the struggles of prey like a three-dimensional map. Its eyes, though capable of penetrating dim light, are secondary to the data it gathers from disturbances. A human hand dipping into the river echoes through the water column as a crisp vibration, telling the caiman exactly where to position itself for the strike. Even the angle of the victim's body matters. Leaning forward shifts the weight distribution, which the caiman uses to predict where balance will fail first. The physiology behind the caiman's strength adds another layer to the threat. Their skulls are built for crushing, not cutting, with teeth designed to anchor rather than slice. Their neck muscles are reinforced by bony plates, osteoderms, that act like internal armor. These adaptations allow them to seize and hold prey with extraordinary stability through dynamic movement. When dragging a human underwater, the caiman's body becomes a fulcrum around which the struggle rotates, turning the victim's own attempts to escape into vectors that help the predator tighten its grip. Local communities living along caiman-rich waters know these risks intimately. Stories circulate of children who never resurfaced after washing their feet at the river's edge, of adults pulled away while rinsing fishing nets, of travelers found only after floods receded, their bodies bearing the signature punctures of a caiman bite. These stories are not presented with horror or embellishment. They are cautionary tales rooted in ecological reality. The river, for all its generosity, is not a neutral space. Thermoregulation also shapes caiman behavior in ways that increase human encounters. During the cooler hours of morning and late afternoon, caimans often patrol the shallows to absorb warmth. Humans entering the water during these periods unknowingly step into zones where the reptiles are already active, using solar-heated eddies as resting spots. Migration patterns tied to seasonal floods further concentrate caimans along banklines, turning ordinary washing areas into hidden ambush corridors. In some regions, symbiotic relationships between caimans and scavenger fish increase the likelihood of interaction. Fish drawn to human food waste attract caimans seeking easy prey, and the entire system folds into a single predatory loop that pulls humans deeper into the reptile's domain. To the caiman, the human body is not a moral category or a symbolic entity. It is movement, vibration, and flesh, a biological object that triggers ancient reflexes. The reptile does not distinguish between a hand rinsing a cup and the leg of a capybara breaking the water's surface. What matters is the opportunity created by leaning too far, by losing footing, by assuming that the water's edge is a boundary rather than a hunting platform. In the end, the truth is stark. When a caiman decides to strike, the ambush is already half complete before the victim understands that anything is wrong. The still water becomes a trap door. The edge becomes an illusion, and once a limb is seized, the human's survival depends almost entirely on whether someone else is there to pull him back before the river claims another life. Here, in these dynamic, muddy thresholds between land and water, the Amazon reveals another of its unyielding lessons. Predators own the edges, and the creatures that wait there, silent, motionless, patient, see no difference between the wild animals they evolved to hunt and the humans who unknowingly step into their sphere of perception. Shallow Amazonian lagoons look harmless at first glance. Warm, tea-colored water curls around the ankles of fishermen pulling in nets. Kids splash in knee-deep shallows near sandbars, their shouts rising above the humid air. Families wade in to rinse sweat and dust from the day's work, the sun settling low behind them, turning the surface into molten bronze. These places feel safe precisely because the water is slow, enclosed, familiar. But beneath that warm stillness, beneath the scattered leaves and drifting silt, something waits with unwavering consistency. Schools of piranhas, milling in loose formation, alert to the faintest cue of weakness or distress. Contrary to myth, piranhas do not launch frenzied attacks on every human who enters their territory. In most cases, they scatter at the turbulence of a confident swimmer or retreat from the splashing of children. Their ecology favors caution. They live among larger predators like giant otters and caimans, and reckless behavior would erase them from these systems long before humans ever appeared. But there is one category of intruder they do not ignore: the compromised human body, injured, exhausted, trapped, or drunk. That is when these fish become brutally efficient, shifting from passive scavengers to opportunistic feeders in seconds. The triggers are simple and ancient. A swimmer with an open wound sends a trace of blood into the water. Even a few molecules can drift far enough to stimulate the chemoreceptors along piranha jaws and gill covers. A drunk man stumbling from a canoe at dusk creates the thrashing turbulence that signals a struggling animal. A villager wading in with a nosebleed after a fall produces the exact chemical signature that piranhas have evolved to associate with dying prey. A resource too valuable to ignore in a nutrient-demanding ecosystem. It begins slowly, almost imperceptibly. A light tap on the toes, a tug at the edge of a submerged foot, a small pressure against the calf. For those familiar with Amazon rivers, these sensations are ordinary. Countless fish species bump, taste, and test anything that enters their domain. But the tap of a piranha is different in intention. It is an exploratory bite, a quick, surgical incision delivered by interlocking triangular teeth capable of shearing through bone. These initial bites rarely draw attention. The victim may feel only a sting or assume a branch scraped past. But the fish now knows something crucial. The intruder bleeds. In enclosed water, blood does not disperse as quickly as in open channels. It forms a faint plume carried by microcurrents into pockets where piranhas gather, transforming the lagoon into a chemical broadcast of opportunity. The first explorers are soon joined by others. Their schooling behavior, usually a defense against predators, becomes inverted into a coordinated feeding strategy. A dozen fish at first, then perhaps 50. Not a chaotic frenzy, but a series of rapid, strategic strikes aimed at the softest accessible tissues: toes, ankles, the tender spaces behind knees. For an intoxicated swimmer, this shift is catastrophic. Alcohol dulls pain perception, meaning the first bites may go unnoticed until the water clouds with blood, or until structural damage, a chunk of skin torn away, forces a sudden realization that something is horribly wrong. Instead of swimming cleanly away with controlled strokes that would intimidate fish, the panicked victim thrashes, splashing unevenly, struggling to orient in the warm, suffocating water. This erratic motion mimics the motor patterns of dying prey. Every kick sends pressure waves into the water column. Every gasp above the surface signals distress. The piranhas intensify, the bites multiply. Small pieces of flesh vanish instantly into dozens of mouths. Piranhas are not large. Most measure under 30 centimeters, but their density and precision compensate for their size. They target areas where resistance is lowest: the webbing between fingers, the lips, the cheeks, the groin, the eyes, the soles of the feet. Their feeding has no malice, no frenzy of rage. It is mechanical, optimized by millions of years in a system where animals die, sink, and must be consumed before decay wastes precious nutrients. In the Amazon, nothing is allowed to rot unclaimed. Human survivors describe the sensation as a burning swarm, as though the water itself has developed teeth. Each bite is small, but the cumulative effect is catastrophic blood loss, shock, and rapid functional collapse. Those who attempt to wade toward shore often fail. Their legs become the primary target, weakening them until they cannot stand, much less walk. They fall, inhale water, and the lagoon finishes what began with a tiny exploratory nip. Documented cases of piranha-related fatalities show a consistent pattern. Bodies retrieved from enclosed lagoons or sluggish side channels often show extensive post-mortem feeding, but many also reveal peri-mortem injuries, bites delivered while the victim was still alive or dying. Hands and feet are among the first areas stripped. Fingers vanish entirely. Lips, ears, and noses disappear, chewed down to cartilage. In some extreme cases, entire limbs are reduced to exposed bone within minutes. These reports are not exaggerated folklore. They come from coroners, police logs, and medical teams responding to drownings, where piranhas accelerated the destruction of soft tissues at a pace few other natural processes can match. Why such efficiency? Part of the answer lies in the Amazon's seasonal cycles. During the dry season, fish become concentrated in shrinking water bodies, heightening competition and aggression. Predators like dolphins and otters hunt relentlessly. Carcasses are rare, and the nutrient economy tightens. Piranhas therefore evolved to exploit any opportunity instantly. A weak, bleeding human in a shallow lagoon is, ecologically speaking, indistinguishable from an injured capybara or a caiman hatchling caught in vegetation. The fish do not recognize humanity, only vulnerability. Another part lies in their jaws. Piranha teeth are arranged in a vertical saw, each blade designed to slice cleanly through muscle. Their bite force, proportional to body mass, is among the strongest of any bony fish. Even the red-bellied piranha, the species most implicated in human damage, is capable of removing a gram of flesh with a single movement. Multiply that by 30 fish biting in rapid sequence, and the math becomes grimly predictable. But to see piranhas as villains is to misunderstand their ecological role. They are not apex predators stalking humans. They are opportunists, essential recyclers in a system where nutrients must be rapidly reclaimed. When a peccary drown crosses a flooded plain and fails, piranhas finish it. When a bird is injured and cannot take flight, piranhas finish it. When a drunk fisherman slips into a lagoon and thrashes rather than swims, they finish him too. In each case, the same rule applies. The strong pass through untouched, the compromised are consumed. This does not absolve the danger. Instead, it reframes it. Humans are not hunted by piranhas. We place ourselves in the ecological slot normally occupied by dying prey. A cut on the foot, a fall from a canoe, alcohol-induced loss of coordination, panic instead of calm strokes. These variables lower us into the category the fish recognize instinctively. Scenes from real incidents illustrate this point vividly. A boy with a minor leg wound jumps into a stagnant pool to cool off in the heat. He surfaces seconds later, screaming, the water below him turning red. A drunk man slips into a lagoon after a village celebration and is recovered the next morning as little more than a torso. A group crossing a shallow channel during the dry season encounters a dense school of hungry piranhas. One member, who hesitates due to a foot injury, becomes the focal point of the swarm. The difference between untouched and attacked often comes down to strength, clarity, and movement discipline. Piranhas do not negotiate. They do not pause to evaluate intent. Their world is structured around patterns of disturbance and chemical cues. When blood enters the water, the pattern changes. When struggling begins, the pattern becomes unmistakable. And the fish respond with the efficiency of a system designed to waste nothing. This is the uncomfortable truth of the Amazon's still waters. Piranhas are not the monsters of legend, but the custodians of weakness. They wait not for opportunity to hunt the living, but for the living to imitate the dying. In the end, the drunk swimmer's nightmare is not an exaggerated horror trope. It is a collision between human vulnerability and ecological optimization. The lagoon does not become hostile. It simply reveals the rules that were always there. And once those rules activate, once the first exploratory bite breaks the barrier between safety and slaughter, the fish finish their work with a precision that leaves nothing to chance and nothing to waste. The forest at night becomes a different planet. By day, narrow Amazonian trails are thin corridors of filtered sunlight, their edges defined by saplings, buttress roots, and the soft rattle of hidden insects. But when darkness settles, when the canopy seals off the last remnants of color and the air thickens with humidity and the scent of wet earth, these trails become tunnels carved through shadow. Hunters, loggers, and farmers move through them with minimal light. A weak headlamp, a flickering phone torch, sometimes nothing but memory and moon-sifted silhouettes to guide their steps. These routes are vital arteries connecting villages to forest plots, fishing camps, and hunting grounds. They are also the exact places where one of the Amazon's most perfectly camouflaged predators lies motionless, waiting with ancient patience, the bushmaster. Few animals are as tightly bound to the forest floor as Lachesis muta, the largest venomous snake in the Americas. The bushmaster does not coil in branches or glide through water. It is a creature of leaf litter, humidity, and stillness. Its body is patterned with jagged diamonds and broken bands that mimic fallen leaves, rotting bark, and the dappled, chaotic texture of the forest ground. When the snake rests along a trail's edge, partially buried under crumbling detritus, its outline disintegrates into the debris. Even experienced hunters can step within centimeters of it without noticing anything at all, until the moment the landmine triggers. This camouflage is not passive beauty. It is a precision adaptation anchored to the bushmaster's ambush lifestyle. The snake selects micro-habitats where leaf accumulation is thick, where temperature and humidity support its slow metabolism, and where rodents, marsupials, and small mammals follow predictable travel routes. Human trails, cleared by centuries of foot traffic, overlap perfectly with these animal corridors. The bushmaster is not attracted to humans. It simply occupies the same geometry of movement, the same narrow spaces where creatures pass in single file. When someone steps directly beside it, the snake interprets the intrusion the same way it would interpret a peccary hoof or the footfall of a large rodent, a threat or an opportunity too close to ignore. The strike, when it comes, is driven by one of the most impressive venom delivery systems among pit vipers. Bushmasters possess extraordinarily long fangs, hinged needles that snap forward with a muscular thrust of the jaws. Their venom sacs are large, capable of delivering a bolus far exceeding what smaller snakes can manage. And unlike many vipers that inject small, metered amounts in defensive strikes, bushmasters often deliver full envenomation in a single catastrophic pulse. The victim, stepping unknowingly onto or beside the snake, feels only a flash of impact against the lower leg, much like stepping on a thorn. But the venom has already begun rewriting the body's internal chemistry. What happens next is a biological unraveling, swift and merciless. Bushmaster venom is a complex mixture of hemotoxins and cytotoxins designed to kill mammals quickly, not through immediate paralysis, but through circulatory collapse. Within minutes, swelling blooms around the bite site, expanding into the calf and thigh. The tissue becomes hot, firm, and agonizingly painful as venom destroys cell membranes and blood vessels. Small hemorrhages appear under the skin, first faint like bruises, then spreading into purple blotches as capillaries rupture. The venom's proteolytic enzymes begin digesting tissue from the inside, liquefying muscle fibers and breaking down structural proteins that hold cells together. Simultaneously, systemic effects ripple outward. Blood pressure plummets as the body loses its ability to regulate vascular tone. Internal bleeding begins in subtle places, gums, nose, the lining of the digestive tract, before accelerating into more dangerous territory. The kidneys, which filter the venom-wrecked debris from the bloodstream, become overwhelmed. Tubular necrosis sets in, rendering them unable to maintain fluid balance or clear toxins. Victims often describe an overwhelming sense of weakness, dizziness, and impending collapse. These sensations are not psychological. They are the manifestations of a body losing its internal coherence. In remote areas, where trails run miles into forest and where transport depends on foot travel or small canoes, this timeline becomes lethal. Antivenom exists, but distance turns it into a theoretical promise rather than a practical rescue. Many villages lack refrigeration for storing antivenom, and even when it is available, reaching a clinic in time requires immediate evacuation. But a bushmaster bite often incapacitates before the victim can walk. Hunters collapse on the trail, unable to stand from pain and rapidly dropping blood pressure. Companions sling them over shoulders or drag them along muddy paths, but the forest becomes an obstacle course. Roots catch underfoot, slopes become treacherous. Humidity weighs heavily on lungs already struggling with venom-induced shock. It is not uncommon for victims to lose consciousness long before help arrives. Fatality rates reflect this geographical reality. In urban hospitals equipped with antivenom and fluid resuscitation, survival is high if treatment begins quickly. But in the remote fringes of Peru, Brazil, Colombia, and Venezuela, places where the bushmaster's range intersects with human necessity, mortality rises sharply. People die on the way to help, carried on makeshift stretchers through ravines, ferried in dugout canoes across swollen rivers, slumped in the back of motorbikes traveling over rough tracks. Some make it halfway, some die within hours, some never leave the forest at all. The tragedy lies not in malice. Bushmasters do not hunt humans, but in ecological overlap. The snake is a specialist in killing mammals on the forest floor. Its heat-sensing pits detect the warmth of small prey against the cool backdrop of leaf litter. Its strike speed evolved to target quick, ground-scuttling creatures like rats and opossums. Its venom composition evolved to stop these animals fast, preventing them from escaping far into the undergrowth. When a human foot steps alongside such a predator, the sensory data is identical. A warm, moving object within striking range. The snake reacts reflexively, not out of aggression, but out of evolutionary certainty. A human leg is simply another large, warm target. Night travel amplifies the risk. On narrow trails, the beam of a headlamp illuminates only a small cone of earth, leaving shadows where a coiled bushmaster may lie. Many bites occur when people walk in single file, the first person passing safely while the second steps directly onto the snake as it coils tighter in response to the initial disturbance. Others occur when someone pauses to adjust a pack or check a tool, placing their foot slightly off the trail's center, exactly where the bushmaster rests to avoid being trampled by larger animals. Even daylight is no guarantee. The snake's camouflage is so complete that loggers clearing brush have picked up what they believed was a fallen branch, only to feel it come alive in their hands. Understanding the bushmaster requires recognizing the delicate equilibrium of the forest floor. This is a habitat built from decomposition and renewal. Leaf litter piles into soft layers that retain moisture and host entire micro-communities of insects, arachnids, and small vertebrates. Mammals trace invisible highways through this substrate, following scent trails and habitual paths. The bushmaster positions itself at the intersection of these routes, a static predator in a dynamic world. Its stillness is not laziness, but strategy, a thermoregulatory and energetic balance that allows it to conserve power until the exact moment a target presents itself. When humans enter this zone, they become indistinguishable from the prey species that shaped the snake's evolution. In the aftermath of a bite, the forest often falls eerily quiet. Companions know the gravity instantly. They bind the limb loosely, knowing that tight tourniquets can worsen tissue damage. They try to carry the victim toward help, but the forest seems to stretch endlessly, each step a reminder of the narrowing window for survival. These journeys form the backbone of countless stories in remote communities. Men who died before reaching the river, women who began vomiting blood halfway to the village, children who became unresponsive mere minutes after the bite. The stories survive because they repeat, not because they are rare. In the end, the bushmaster embodies a simple truth of the Amazon. The forest floor is not empty. It is layered with life, hidden, patient, and exquisitely adapted to the geometry of human movement. To walk its trails is to enter the domain of a predator that neither fears nor seeks us. A creature that responds to warmth, motion, and proximity with the precision of a landmine waiting beneath leaf litter. And once it fires, the forest becomes a race against venom, distance, and time. Here, in the dim, humid corridors of night, the Amazon delivers one of its most uncompromising lessons. A single misplaced step can become the fulcrum between life and death. And to the bushmaster, that step is nothing more than another mammal entering range. Night in the Amazon thickens like smoke. It doesn't simply fall, it gathers, settling into the hollows between tree trunks, seeping along riverbanks, filling the spaces between houses built of palm slats and thatch. In remote villages where electric light is scarce or absent, people drift to sleep in this deep, primal darkness. The air cools slightly, though humidity clings to skin like a second layer. Chickens mutter on their roosts. Dogs curl into depressions in the dirt. Hammocks sway softly in the breeze. It is a world calibrated for rest, and that is precisely why another creature begins its shift the moment human consciousness loosens. When most of the forest sleeps, vampire bats rise. They leave their roosts in hollow trees, abandoned buildings, caves, and the undersides of remote bridges, emerging in fluid waves like shadows with direction. These bats are small, barely the size of a clenched fist, but their presence shifts the atmosphere of night. Their flight is nearly silent, each wing beat engineered to slice through stillness without announcing intent. While fruit bats and insectivorous species move high in the canopy, the vampire bat stays close to the ground, gliding just above the forest floor, scanning for warm bodies radiating faint heat signatures into the cool night air. In remote Amazonian villages, those warm bodies include humans. The bat's approach is a study in stealth. It detects mammals through a combination of scent, sound, carbon dioxide gradients, and a form of infrared sensing that allows it to pinpoint blood-rich areas near the skin's surface. A sleeping human lying in a hammock or on a simple palm mat presents a map of opportunity. Exposed toes, an ankle draped over fabric, a hand resting outside a blanket. The bat lands not with the abrupt thump of a bird, but with the delicacy of a leaf settling to the ground. It crawls forward on elongated thumbs and agile hind limbs, its movements eerily terrestrial for a creature of the air. Feeding begins not with a bite, but with preparation. The bat uses its razor-sharp incisors like surgical blades, shaving a patch of skin so thinly that the victim rarely wakes. These teeth are extraordinary, not only sharp, but self-sharpening, sliding against one another like microscopic whetstones every time the bat closes its mouth. With the surface cleared, the bat makes a tiny incision, often no larger than a pinprick, into capillary-rich flesh. It does not tear or chew, it opens a hole. Then comes the biochemical magic. The bat's saliva contains a potent anticoagulant known as draculin. Once this compound enters the wound, blood refuses to clot. Instead, it wells upward in a slow, steady seep. The bat drinks by lapping, not sucking, using its tongue to draw up the trickle of warm fluid that its victim continues to produce involuntarily. A single bat may feed for 20 minutes, undetected, its weight so slight and its touch so delicate that even a light sleeper remains unaware. When finished, it simply steps backward, lifts into the air, and fades into the night again. If this were the whole story, vampire bats would be unsettling but manageable. Tiny thieves stealing tablespoons of blood in exchange for mild irritation. But in the Amazon, the danger is not the feeding. It is what rides hidden inside the bat. Rabies is the most notorious passenger. Unlike the bacteria and parasites that many bats carry, rabies exploits the nervous system with ruthless efficiency. When introduced through a bite, even a shallow one, the virus begins traveling along nerve pathways toward the spinal cord and eventually the brain. It moves quietly, often for weeks, without symptoms. In this incubation phase, a person may feel perfectly healthy, unaware that the pathogen is multiplying within neurons, hijacking cellular machinery, preparing an assault that will end in almost certain death if untreated before symptoms appear. Vampire bat-transmitted rabies outbreaks in Amazon communities follow a grim pattern. It begins with a cluster of bites, usually reported only after the first person falls ill. In villages where people sleep without mosquito nets or proper house sealing, bites occur frequently during the rainy season when bats face greater competition for livestock blood or when domestic animals are scarce. A family may wake to find several members with small wounds on their toes or faces. At first, nothing seems wrong. Days pass, life continues. Then someone develops fever or confusion or a tingling sensation at the sight of the bite. A child becomes afraid of water, a hallmark sign, as hydrophobia emerges from spasms in the throat triggered by swallowing. Another adult grows agitated, delirious, then violent. Someone else cannot tolerate bright light or breezes on their skin. Panic spreads through the community as people realize what has happened. The fear is justified. Once rabies symptoms appear, survival is almost non-existent. Multiple Amazonian outbreaks have taken half a village within a month. Epidemiologists who later investigate find the same underlying pattern. Dozens of people bitten over a short period, often by the same small colony of bats. Bites concentrated on feet, elbows, ears, or lips. No access to post-exposure prophylaxis. No communication link to clinics that hold the vaccine. And no cultural expectation that a tiny bite could bring an unstoppable neurological storm. Yet rabies is only part of the story. Vampire bats carry an expanding viral portfolio, an ecosystem of microbes that co-evolved with them over evolutionary time. Some remain benign to humans, others are potential spillover threats. These viruses travel through blood, into tissue, and deeper into the nervous system, where they can hide, mutate, or occasionally erupt into more powerful outbreaks. The bat itself suffers nothing. Its immune system tolerates viral replication with an elegance mammals rarely exhibit. Humans, however, become unwitting hosts, warm, immunologically naive bodies in which these microbial stowaways can replicate with catastrophic results. Behind this biological horror lies a broader ecological truth. Humans sleeping in open structures blur the boundary between village and forest. Houses built without solid walls allow bats to enter as easily as mosquitoes. Sleeping on the floor or near ground level increases exposure. Deforestation pushes bat colonies closer to human settlements. Livestock shortages drive bats to test human prey more frequently. These factors do not cause outbreaks. They assemble the conditions for them, layer by layer, until one night's cluster of bites becomes a village-level tragedy. In some communities, elders recount stories of entire families lost in a single wet season. One generation is marked by the memory of siblings who deteriorated one after another, each exhibiting the classic late-stage rabies symptoms: tremors, hallucinations, violent agitation, eventually coma. Villagers recall how they burned torches all night to keep bats out, or slept in groups to reduce exposure. They describe waking to find small blood spots on their blankets or tiny punctures along their toes. These testimonies reveal not folklore but lived epidemiology, an understanding born from experience rather than laboratory science. And yet, despite the fear they inspire, vampire bats are not malevolent. They are specialized feeders, beautifully evolved to exploit a niche few mammals occupy. Their thermoregulation, sensory adaptations, and digestive physiology form a coherent survival framework. They track heat with precision. Their saliva keeps blood flowing. Their kidneys process large amounts of fluid efficiently. The bat's feeding strategy is not brutality. It is the execution of ecological necessity. The danger arises when humans enter that ecological equation without adequate protection. We become targets, not because bats hunt us, but because from the bat's perspective, we are simply sleeping mammals with exposed blood sources. Only after the bite does the more insidious predator, the virus, awaken. Rabies hitchhikes from bat to blood, to nerve to brain, using the very structure of our nervous system as a highway. Humans, with our long axons and slow-responding immune defenses, provide an ideal environment for viral replication. In the Amazon, we often speak of predators with teeth, jaguars crushing skulls, caimans dragging people underwater, anacondas coiling around ribs. But vampire bats remind us that some of the deadliest predators are too small to see, too silent to hear, and too humble in their approach to inspire immediate fear. Their bites barely hurt. Their presence is almost invisible. Yet they can transform a quiet night into the beginning of a village-wide crisis. And so the chapter closes with an unsettling truth. In the rainforest, humans are not only prey for animals, we are fertile ground for microbes. A vampire bat may drink a few drops of blood, trivial, almost polite in its execution. But what moves through that wound, what infiltrates nerves and climbs toward the brain, is something far older, far more ruthless, and utterly indifferent to the larger predator killed or the smaller predator fed. Sometimes, in the quiet hours before dawn, the Amazon reminds us that we are not just bodies with bones and breath. We are walking factories for the organisms that ride inside our blood, waiting for the smallest doorway to step through.